Imagine running a complex AI system where multiple agents, GPUs, and microservices are constantly working together, but you have zero visibility into what's happening inside. Sounds risky, right? That's where observability comes in. In this video, we'll break down a powerful production-grade observability stack designed for modern AI workloads on Kubernetes. From metrics and logs to traces and alerts, you'll see how every layer works together to give complete system visibility. At the core of this observability stack is Prometheus, which continuously scrapes metrics from all pods, including Kubernetes system metrics, application-level metrics, Istio service mesh data, and even GPU-level insights from vLLM workloads. To extend this further, Thanos enables long-term storage and allows querying across multiple clusters, making it ideal for large-scale deployments. On top of these metrics, Grafana dashboards provide clear and actionable insights. Custom dashboards track AI agent health, including replica counts, error rates, and Kafka lag per agent. GPU utilization dashboards show memory usage and tokens processed per second, while cost dashboards help monitor compute usage per task, ensuring efficiency. To proactively handle issues, Alert Manager integrates with PagerDuty and triggers alerts when critical thresholds are crossed. For example, if Kafka lag exceeds 500 for more than 5 minutes, if agent error rates go beyond 5%, if GPU memory usage crosses 90%, or if pods enter crash loop backoff states, alerts are instantly sent to the team. For distributed tracing, Telemetry plays a key role. The OTEL collector runs as a daemon set, collecting traces from all services and exporting them to tracing backends like Jaeger and long-term storage such as S3. With W3C trace context propagation through Istio, every request can be tracked end-to-end. Using Jaeger or Tempo, you get a complete distributed trace of the workflow, from Kafka message consumption to orchestration, specialist agents, model inference, and final result publishing. This makes it easy to identify bottlenecks and debug failures in complex pipelines. Logs are handled by FluentBit, which collects container logs from all pods, enriches them with Kubernetes metadata like pod name, namespace, and node details, and streams them to storage systems like Elasticsearch or CloudWatch logs. These logs can then be explored through Kibana or OpenSearch, enabling powerful full-text search, structured log analysis, and secure inspection of AI prompts and responses with sensitive data redacted. For GPU-level visibility, NVIDIA DCGM Exporter runs on GPU nodes and exposes critical metrics such as GPU utilization, memory usage, temperature, power consumption, and NVLink throughput, all integrated into Prometheus for unified monitoring. Finally, SLO dashboards powered by Sloth help define and track service-level objectives. Metrics like 99.5% task success rate, P99 latency under 5 seconds, and Kafka lag within 30-second thresholds are continuously monitored. Burn rate alerts ensure that any risk to these objectives is detected early, allowing teams to take action before users are impacted. By combining metrics, logs, traces, and intelligent alerting, this observability stack provides complete visibility into modern AI systems. It not only helps in monitoring performance, but also ensures reliability, scalability, and faster debugging. If you found this breakdown useful, don't forget to like, share, and subscribe for more deep dives into cloud, Kubernetes, and AI infrastructure.